Hello and welcome everyone to week 14 lecture for the Weld 40 Mount San Antonio College Introduction to Welding course. And what I wanted to talk about during this lecture is how the welding industry works and how we go about welding things. Because before we go to weld something, an engineer has to put together a procedure for us to follow so that we know that when we join these materials, we have strength in the material that's going to be able to be applied to where it's going to be used. In other words, it's going to be able to absorb any of the forces that are required for it to support. And the way this goes about, it begins with what's called a welding procedure specification. It's your recipe. And so you have to write down what we want to weld. And let me just say before I get going with this is kind of meant to be fun. I don't mean it to be, I'm not going to absolutely test you on this, but I just want you to understand the concept of it and how the welding industry works. You start out with a recipe. So depending on what you want to weld, let's say you want to weld an A36 material to an A36 material, which is just your common mild steel, structural steel. And it's just common steel that we would find at any project. That would go into a WPS. And you would say, hey, look, this is what I want to weld. Also, on the other hand, let's say you want to weld a piece of paper to a pen. Okay, that's just something that I just mentioned right now. Okay, so obviously I want to weld a piece of paper to a pen. So I have to write down what I want to do. Okay, this particular type of paper to this particular type of pen. And I want to weld it with, well, let's say a welding rod, right? I'm gonna hook this up and I'm gonna try to run a weld bead across this pen to a piece of paper. My point being is that it wouldn't work, right? If I took a welding rod and I tried to weld a marker to this piece of paper, it wouldn't work. So I want to just say this to you is that some of the WPSs that are written, they don't work. Maybe whatever you're using to piece of A36 material to a piece of copper. Okay, let's say you're going to weld a piece to a piece of copper and you want to use a particular welding rod. So you go to weld that and it doesn't hold together. Well, that's the purpose of the procedure qualification record. So first you start out with a recipe, what you want to weld, and then you actually have to qualify that WPS. So once you put together the recipe, you actually run the qualification record, meaning that you actually do the work. And then after the WPS qualifies, now you've got a qualified procedure. So these two go hand in hand. The WPS and the PQR, those are always together. Sometimes you'll write a WPS, obviously, and when you go to do the qualification record, it fails. So the failed part of that goes with the WPS, and we would always just put them in the back file. You know, it would just be, hey, we tried it and it didn't work. And this had to do with whether we were brazing, whether we were soldering, whether we were welding stainless, Inconels, Manels, aluminums, different types of steels. Or you could try to weld a piece of aluminum to a regular piece of mild steel. Well, you have to find out if the welding rod that you're going to use to join those two, you have to find out if it's going to work. So once it's welded and then you perform a test, whether it be a macro etch, it might be a chemical test to it, or you actually do a bend specimen to it, but you qualify this WPS. Once it's qualified, the two go hand in hand. My point on the paper and in the marker was only to point to you that we don't tell you exactly what you're going to weld. You can try to fuse it together. But there's a procedural way to go about it in qualifying it, so that when a person goes to produce that weld, they have to be using the materials that are specified, and they have to be using the filler rod that's specified at the amperage range that's specified, and everything else that goes with the procedure itself. All right, so once we get a WPS and a PQR and we get something that works, now we can certify the welders, and that's the WQR, the welder qualification record. So at that point, we bring in the welders, which is this demonstration right here. This is actually a welder qualification record right here that has all the information, has the WPS numbers on here, and also has the test that the welder did. And you can see the root bend and side bends here, and that they performed satisfactory, and then the inspector and would sign here to authorize the certification of the welder. But all the welding, this happens to be a submerged arc certification, so the submerged arc filler material and such and so forth, also referencing the WPS and PQR that is used, that this welder is being certified to. That's what I'm trying to tell you. That's how the welding industry works. So we have the materials, and then the welder certifies to it. Once the welder certifies to it, now the welder can go outside and start doing the welding. So here's one that I had at a nuclear plant. I used to work at the San Onofre nuclear plant. And every time someone did any welding there, and I'll do my best to kind of draw, but if I had a, no, this doesn't, right here, and see if this one. So if I had a pipeline, if I'm welding a pipeline, I would have a weld here, maybe there'd be a weld at the midway, and a weld here, and a weld here, and a weld here. Each one of these welds at a nuclear plant would have a welding record. And that's what I'm holding in my hand right now. So specifically for that weld right there, we would have the WPS, the PQR, and we would know what welder made that weld. We would also know any cleanliness, any fit-ups, any preheat, interpass temperatures, such and so forth. That would be what this sheet would be used for, just for that. And again, each one would have a specific weld record. So I'll kind of bring this to you and kind of try to show it to you. This is an actual one. Well, it's not, there isn't any information there, but this is one that was used at the San Onofre nuclear plant, and all the information that was used. Here at the base of it, there's hold points for the welding foreman, for the welding engineer, quality control, and also if it's a boiler application, an authorized inspector would get involved. But in this part of the weld record, they would literally mark either a witness or a hold point where they wanted to go and they wanted to be involved with these particular stages of the welding process itself. So if they wanted to see the fit up, they would come over here on 23 and they would put a hold point here, either for the welding engineer or for the quality control. If they didn't want to get involved with the weld, they wouldn't mark anything. So we would just continue on, and obviously the welder and whoever is supervising would be responsible for the weld that's occurring. But I just kind of wanted you to get the concept of it. And I want to try to take it a step further, because in the welding code, there's actually pre-qualified procedures. In other words, these have already been done. They've already done WPSs and PQRs, and they know that it works. So if you use these two particular types of material and you put this particular type of joint together, they considered it pre-qualified. So I don't want to get this too confusing, but I just want to let you know in the code there's joints that are written in there that are pre-qualified, that if you set it up exactly that way and go about that welding, you can go ahead and proceed and do the work. If you're a qualified welder, we'll talk about that in just a moment. But most people, most fabricating shop, most companies, they write their own WPSs and PQRs. They have on their own letterhead. They put together their own welding program, and the welders that are in the shop qualified to the welding, the WPSs and PQRs that are specific to that company. But what I wanted to demonstrate to you was a pre-qualified weld. This happens to be the weld that a person gets certified to. So I actually brought in a certification plate for someone that's going to get Los Angeles City certified. And this is what it is. This is what it looks like. So you can see that it has an included angle here. That's 45 degrees. And there's a gap here. That's a 1/4 inch gap. It's a 1 inch thick material. Each plate is 3 inches by 5 inches, and I'll show you all that. I'm not just saying these words. This is all written in the code book itself for a person to get certified. But for a person to get certified, you would have to put weld in here and, of course, fill this groove, and then we would take some side bends from this. But this happens to be a pre-qualified weld right here. Okay, and that's what the weld plate looks like. And we'll talk more about that in just a moment. But my statement to you, what I wanted to say right now, is that weld that I just showed you is 45 degrees included angle here. That means that each one of these bevels is 22.5 degrees. And we have a 1/4 inch gap here between the two plates, and then we have a backup strip here. I think by code that's allowed to be anywhere from a 1/4 inch to 3/8 thick for this backup plate. But this is a pre-qualified fit up. So I wanted to just make a comment on how could I take a pre-qualified joint and then work it into me doing my own WPS and PQRs. Okay, well, let's say I'm going to do 500 of these welds. I own the company. I'm going to have to employ 20 welders. I'm going to bring them all in, and I have to make 500 of these welds. But I'm kind of greedy. I want to go about this in a quicker way. So let's say that instead of 45 degrees, I want to make this 35 degrees, like this. And maybe instead of a 1/4 inch gap, I want to make this a 3/16 inch gap. So in essence, I'm gonna steepen the angle, and I'm gonna decrease this gap. Okay? And the reason why I'm doing this is because I can weld it faster. I can get the weld done quicker. So I'm gonna save money. And so I've reduced the angle, I've reduced the gap. However, this is not considered pre-qualified. So now I have to qualify this. So I would put together my recipe saying, okay, I want to join these two materials. I want to use a 35 degree included angle. I want to use a 3/16 inch gap. And then I have to qualify it. So I actually have to have someone weld that particular setup. Once I weld it, I have to do my side bends on the plates and qualify it. All right, so let's say, all right, it works. Let's say it works, right? So all I see is dollar signs. I see money that I'm gonna be saving putting all this work together. And I can't wait to get started. So now I've got this qualified. So now I bring the welders in. And when I bring the welders in, I have problems. I have problems because the angle isn't quite opened up enough, and this 3/16 doesn't quite get it. They can't get the electrode quite in there tight enough in order to produce the weld. So I start doing my bends on this and I start getting failures. The welders can't qualify to my 35 degree and 3/16 opening. It's nothing more than just an example to you that yes, I could try to save money in this, but if the welders can't qualify to it, it isn't workable. So in this case, it would be another failed WPS and PQR that would go in the back of the file. After I started seeing the welders and that they weren't able to weld in this tightness of that particular setup of the two plates, then I would just disqualify it and I would just set it in the back folder and just continue on from there. So that's kind of the oversight of how the welding industry works. That each time a welder goes to weld something, there's a procedure for it. And we always go back to, on if something failed, where's the WPS, where's the PQR, and did the welder follow these procedures when they were doing the weld? I wanted to take a moment and talk to you about the LA City certification, because most people in the welding program want to eventually get certified, and that would allow you to go out into the industry, of course, and whether it's a fabrication shop or out in the field on a building, to go ahead and just walk onto the site as a certified welder, become employed, and start welding. But keep in mind, when you go to do that welding, you're doing it following the WPSs and PQRs that are already have been established for each one of the weld joints that you're going to be putting together. An LA certification, it costs $54 to take the written test. It costs $64.80 after you pass the written test. And then to take the actual plates at Mount San Antonio College, it's $100 to take the plates. The written test, you're going to have to get the code book in order to pass this written test, because it's an AWS D1.1 code. Right now, at this time as I'm writing, it's $560 for the actual code book. And that's the actual booklet that you'll use in order to reference when you take this written test. Here at the college, they offer a certification at 70C, and it actually preps you for the LA City certification test. In fact, the midterm and final are very similar to the actual test itself, but it's in preparation of you qualifying, getting prepared, if you will, in order to take the test for LA City. The written test itself is 50 questions. It's 30 closed book and 20 open book tests. So you're going to have to be able to use this code book. At 20 open book questions, you're going to have to actually go into the code book and open it up and find the answer, and then write down what paragraph you found the answer, so that they know that, one, you have the code book, the other one is that you know how to use it, you know how to reference it. And again, the 70C class here at the college prepares you for that step for you in order to pass that written test. Here at the college, we offer shield metal arc welding, stick welding certification, flux cord arc welding. We also offer the light gauge certification. So for those of you who want to get certified, I'll talk to you in just a moment about that. I know earlier I mentioned you that this is an actual certification plate right here that's getting ready to go. And two things to mention at this time. This is actually from the AWS D1.1 code. You can see the plate right there. And that's the plate that I was just holding up. This is straight from the AWS D1.1 structural code, and it gives you the dimensions of the plates, the 3x5. It also tells you exactly where to take the coupons. If you'll notice, right from the center of the coupon, 1 inch each way is the edge of the side bend specimen that's removed. Okay, and then this is a write-up of, this is one of the other handouts that you all can print and take a look at. But this shows you the LA City certification test where you're doing one weld in the vertical position and you're doing another weld in the overhead position. It's the exact same plate, you're just welding one in the vertical position and one in the overhead position. So what do you have to demonstrate when you get certified? Well, first, you'll have to weld the plate. So you'll actually have to weld that joint that I was just holding up. You'll have to weld it all the way up with the cover passes. And then what happens is they take those two side bends that was on that, marked on that sheet, we cut those out. And then we take those and we bend them into a U pattern. And let me show you what those look like. So these are actually test coupons right here. So here's one that was bent in the U shape. And if you look real close, you can see the side view of the weld. In other words, the welder welded this whole thing up and it's very, very clean. So this is a passing coupon. This would pass. So this would be one of the coupons. This is another one of the coupons. And I picked this one because it had some discontinuities in it, and see if we can get a good view of the bevel of the plates are right there on the side. I hope that you can see them in this view, but you can see the slight opening there. So what's allowed when you do these side bends, you're allowed anything up to 1/8 of an inch. Anything larger than 1/8 of an inch fails. Also, cumulatively, you're allowed 3/8 of an inch. So that's quite a bit. Cumulatively, we actually use we look at this very, very carefully. We use a magnifying glass and a micrometer to measure each one to make sure that we are within the limits. Anything cracking from the corners don't count unless it's got slag in it. So if you didn't clean the slag out of the weld, and the corner opens, that would be a failure. But anything that would open from the edge, if it's clean, wouldn't count. But in essence, it has to, we read this face, and that determines whether or not the coupon passes. So you would have 2 of these coupons for the vertical plate, and 2 of the coupons for the overhead weld. All 4 coupons are bent, and they would all have to pass in order for you to be certified. And that's what the LA City certification test is involved with. So in other words, I have this weld with the backup plate, and you as the welder, because you have to demonstrate that you can place the weld down in a proper way. In other words, earlier when I was talking to you, we know that the WPS and PQR, we know that that works because it was qualified. But now we have to qualify the welder, and that's what I'm talking about right now. In other words, we give you this plate that's all prepped to go. It's got this strong back on it because as you weld this, these plates are going to try to pull into each other. So we put a strong back on the back side. But the welder has to demonstrate that they can place these welds in here in a workmanship-like manner, all the way up top and the cover passes across the plate in a proper way, in a clean way, removing all the slag, no porosity, no inclusions of any kind in the weld itself. So when it's placed properly and we do the side bends, it passes. And quite frankly, you know, most people that take the certification, when they've gone through the program, pass. That's the truth. I mean, you have to put your time and energy towards it. None of us can just give that to you. But if you put enough hours and time and energy towards it to learn, there's certain techniques when you're welding in the vertical position and certain techniques when you're welding in the overhead position. You should be able to pass this welding test. The last thing that I wanted to talk to you about is just kind of because I was a deputy inspector for structural steel for a number of years, and I was involved with some repairs on some buildings. And I wanted to talk to you about what happened after the Northridge earthquake in 1994. What happened in the Northridge earthquake, if you look at a building, any building, as you're walking in downtown somewhere and anywhere you go in the United States, these buildings are built with a structural steel frame, and they have these columns right here. These columns go down to bedrock. Now, they'll either you know, pour a case on, but they'll drill down to bedrock. In other words, something solid that the building can sit on. Or they'll drive piles. It is literally like a concrete column, if you will, and it's reinforced, and they drive it into the ground until they hit refusal. But whatever way they do it, it has to be strong enough in order to support this building and the live loads and dead loads that are on it. Namely, you know, furniture, desks, books, things like that are dead loads, and then you have the live loads, which is actually people walking in the building. And of course, to support all the material of the building itself, columns, roof, air conditioners, and such and so forth. This building is only as strong as what it's sitting on. And I know you've seen, you know, buildings that actually start to tilt or they actually fail. Particularly when an earthquake happens, and it's because of this situation of what the building itself, either how it was joined or what it's actually sitting on. If it's sitting on soil that can't support the weight, right, it's going to lean over time. The building itself will favor the weakened side type thing. Well, when an earthquake happens, the earthquake not only gets this rolling movement where you get this up and down type movement, but you also get the side to side movement also. And all of that gets transferred into, and I'll show you on this upper picture here, into the beams of the building. And then the beams, because you have primary and secondary beams. You have the main beams, and then there's like what we call gingerbread, just the secondary smaller beams. But the weight transfers into the beams, into the column, and then this column transferred it into your solid base of the building. In other words, it absorbs it. The whole thing absorbs within itself. Well, this connection right here, where the primary meets the column, we call these moment connections on a structural steel building. So typically here you would have high strength bolts right here to connect this column. But also in addition to that, a welder would be sitting on it's an I-beam. It's in this shape right here. So the welder sits up here on the I-beam and welds these flanges to the column itself. So if you're not familiar with an I-beam, this is a flange. This is called a web. And then you have another flange here. But these flanges, they're welded right to the column itself. So this is your primary right here, and how that is welded right there to the column. That's what I'm trying to demonstrate right here, where it would be welded right to the flange of the column, where these are welded. So the upper flange and the lower flange are all welded, and then you put the high strength bolts here, and those are torqued. And that's called a moment connection. And on the drawings itself, it tells a person where these moment connections are. But again, that's to support the weight and also to take care of any potential movement that an earthquake might cause. What happened in 1994 was the Northridge earthquake hit, and I ended up on a Hewlett-Packard building. And in the building itself, what happened was there were cracks that propagated from this lower flange into the column, which meant we had to go in there and open up these flanges and the web. This is the web of the I-beam. It's this part right here of the column. So I'll try to, so this is the primary is connecting, and we're doing this weld right here to the column. I'm showing it this way. But this is the web right here, and the crack would go right into the web of the column. And of course we had to repair all this, and we had to make this repair on the web. And when we were doing that, I got a deputygram from the local jurisdiction where we were doing the work, and the deputygram told us that henceforth all backup strips will be removed on the bottom flange, and we have to air arc the root out of the bottom flange. So I'm going to try to show you what happened and what I'm referring to. What I'm referring to is a welder sits on this top flange, and they can easily reach this. They can easily do this welding because it's the top flange. This one's easy to weld. But when the welder goes to weld the lower flange, they have this web in the place. See right here, it's halfway. So when they reach over to do this weld, they go halfway right here, and then they reach over the other side and they do the other weld. But it was right in this area, right here, where they were getting all the slag entrapment. And after the Northridge earthquake, that's when that was stopped. In other words, they have to remove this backup strip, backup plate on this lower flange, and they had to air arc this weld to make sure that where this web interfaces, that there was no buildup of slag in that area. So in essence, it caused the welders to be much more concerned when they're doing the welding. As opposed to just reaching over, doing a quick weld here, and then reaching over and doing a quick weld here without much cleaning, they ended up with slag entrapment right here, and that's what was causing this crack to go into the column itself. Anyway, if one of the people here at watching find that interesting, then it's all worthwhile. It was something very real, and since then, in 1994, all lower backup plates are removed on moment welds, and this area of the web itself on the columns, those were all checked to make sure that where the primary and the columns meet, that there isn't any slag inclusion. An interesting concept on this is that if you're a building official, right, and you see the physical damage to a building, and of course you go in and you do the repairs, which we did, and it was all done very well and all accepted, and eventually the building went back in operation. However, it's very, very difficult to enforce things like that to an owner of a building. So if you're the building official and you got to go over to the building next door, right, and you don't see any physical damage, there's no cracks, the drywall doesn't show any damage or whatever facial finish that they have. And so how do you discreetly tell an owner of a building that you want to go in and open up one of their connections? And do you have the right to do that? So it gets into the ethical part of what a building official does and what they can enforce, and whether they can go in and maybe check a building if they suspect that there might be damage to it, maybe open up one of the connections. But that would be in cooperation with an owner of the building itself. But very, very interesting questions that enter into the building department when they have to handle these type of situations. So that kind of wraps it up. This was just meant to kind of give you an oversight of how the welding industry goes about their work. Next time that you're going to maybe braze something together, or you're going to join dissimilar metals, maybe stainless steel to structural steel to a regular mild steel type plate, just know that there's a WPS and a PQR to back it up, and you as a welder, you also qualified to it, and you have to follow that procedure so that the engineer gets the structural value of the finished weld itself when you're completed with it. They may ask for a die penetration. They may ask for some kind of ultrasonic inspection, or possibly an X-ray to verify that the weld was done properly, in addition to everything else that we talked about, the WPS, PQR, and the welder getting certified itself. But it's a way of keeping the public safe, for one, but the industry safe also in the way that we go about the business and the purpose of the welding codes itself. All right, thanks everyone for listening.